Hi friends, and welcome to another session on chemistry. Our topic for today is reversible and irreversible reactions. Let's find out what they mean. The key concepts covered in this module are characteristics and examples of reversible reactions and characteristics and examples of irreversible reactions. Alright friends, let's begin our session by looking at a few common examples of reversible examples and irreversible reactions shown here. Okay, let's move ahead now. Now friends, all of us love to eat ice cream, don't we? But the moment we get one, we need to eat it very fast because it melts. Now what happens when the ice cream is melting but we still want to eat it in the solid state? What do? Well, let's find out. The melted ice cream again can be cooled to retain its original state of yummy ice cream. In other words, reactions which can be reversed are called reversible reactions. A reversible reaction is a chemical reaction where the reactants form products that in turn react together to give the reactants back. So the next time you're holding an ice cream which is melting, we know that it can be reversed. Now let's have a look at the characteristics of reversible reactions. What are they? Reactions which are reversible in nature have the reversible sign between the reactants and products. A plus B can react to give us C. So here we see that reversible reactions can be reversed to get the products from the reactants and reactants from the products by changing a few conditions such as temperature or pressure during a reaction. An example of a reversible reaction. The formation of ammonia from nitrogen and hydrogen by Haber's process is one of the examples of reversible reaction. We will learn more about this process elaborately in higher classes. Now let's move on. Have you seen burning wood or burning coal? During winters we have the campfires, and to keep ourselves warm, we normally burn wood or coal. Now what happens when we do this? Well, as usual, let's find out. The burning of coal or wood results in the formation of ash. Now friends, I have a simple question for each one of us here. Can we get back wood or coal back from the ash obtained? Well, the answer is no, definitely not. Why do you think this happens? Well, let's find out. This brings us to our next topic, irreversible reactions. Let's find out what this means. This is because burning of coal or wood is an irreversible reaction. An irreversible reaction is unidirectional, which means it is not reversible in nature. So friends, the next time you want to burn something, think twice. We now take a look at the characteristics of irreversible reactions. In an irreversible reaction, generally one or more substances separate out in the form of precipitate or insoluble substances. Hence, all precipitation reactions are irreversible in nature. We now look at an example of an irreversible reaction. Take a look at this formula. We see that the reaction of sodium sulfate with barium chloride to form barium sulfate and sodium chloride is irreversible in nature. Let us now summarize what we've learned today. We learned that reactions which can be reversed are called reversible reactions. A reversible reaction is a chemical reaction where the reactants form products that, in turn, react together to give the reactants back. Next we learnt an irreversible reaction is unidirectional, which means it is not reversible in nature. We also learnt that in an irreversible reaction, generally one or more substances separate out in form of precipitate or insoluble substances. Hence, all precipitation reactions are irreversible in nature. Lastly, we learnt that the burning of coal is an example of irreversible reaction. With this, my friends, we come to the end of another very interesting session, and we hope you've had fun while learning.